this is the key to Worksheet 7, Part B. And on Part B for this topic, that's where we had these compound inequalities. So remember, compound inequalities where you had two inequalities and it looked like this. Now, in some other situations which you're going to deal with, you could have compound inequality that has an or statement or an and statement. But for us right now, it just looked like this. Okay? And then knows the directions, says write the solution set in interval notation, also graph the solution set. All right, so let's do number one. So number one, we have negative 3 is less than 2x minus 1 is less than 4. So we have this compound inequality. And when solving a compound inequality, you want to go ahead and get the variable by itself in the middle. So you want to find your solutions. So you want to find out what values of x will make this right here, will make this expression less than 4 and at the same time greater than equal to negative 3. Okay? So what you're going to do is just think of it this way. If you just had this linear inequality, you would, remember this is a linear right here, you would go ahead and add 1 to both sides, right? We'll do the same thing here, though. You have to add 1 to all 3 parts. There are 3 parts here. 1, 2, 3. Then let's combine like terms. So I have negative 3 plus 1 is a negative 2 is less than, this is 0 here. So I get 2x in the middle is less than 4 plus 1 is 5. And then finally, if I cover this again and I say, well, if that was all I had, then how could I get x by itself? Well, I can get x by itself by dividing both sides by 2. But remember, you have a compound inequality, so you have to divide all parts by 2. And so now reducing, simplifying, I get negative 2 divided by 2 is a negative 1 is less than or equal to x is less than 5 halves. So there's your solution. So your solutions are any real number that's between 5 halves and negative 1. Notice one has equal sign, the other one does not. So how does that look? Okay, so first of all, there's your solution. Your inequality in terms of solutions. So your solutions are any number between negative 1 and 5 halves, including negative 1, but not including 5 halves. 5 halves is not a solution because there's no equal sign here. So let's look at the graph. So here's what the graph would look like. So you put your endpoints here, your end numbers, so negative 1 and then 5 halves. And remember, in the number line, you always go from smallest to largest. Smallest to largest. Negative 1 must be listed first. 5 halves must be listed to the right. Notice you got to think about, well, do I use brackets or parentheses? Well, there's an equal sign here, meaning negative 1 is a solution, so you have to use bracket, pointing to the right. And then over here, for 5 halves, you have to use parentheses because there's no equal sign here, pointing to the left, because it says less than. And then you should just shade in. Notice no arrows. Remember that, no arrows, because it's bounded. Your solutions are bounded by these two numbers. It's not going to infinity, and it's not going to negative infinity. And so your interval notation then, you just read it from here. So you're going to say bracket, negative 1, comma, 5 halves with parentheses. All right. Now, just to remind you, if they asked you for set builder notation, just like in the previous lessons or previous problem set, you're just going to say the set of x's such that, and all you do is just rewrite this over, such that negative 1 is less than or equal to x, which is less than 5 halves. And that's all you do. All right, number 2, let's do number 2. So number 2, I'm going to go ahead and put number 2 here. I think I have enough room. You have 1 is less than 3x plus 1 divided by 2 is less than or equal to 3. Okay, so we have this compound inequality, and again, I want to get x in the middle, but I do have a fraction here, so you got to think about what you've done previously. Well, if you just had this, you got to clear your fraction, so the LCD is 2. So you're going to multiply all parts by 2 to get this to be a 1 down here. So you're going to say times 2, times 2, times 2, just like that. Okay? And so maybe I should have just, let me go ahead and rewrite this over like this, so that way, all right. Okay, so here is the problem. 1 is less than 3x plus 1 divided by 2 is less than or equal to 3. So I'm going to rewrite the problem over so it's not messy right here. So that was the original. So I'm going to go ahead and rewrite it over, leave some space here. and then leave some space here. Okay, and then we're going to do the same thing. All right, so I got to clear the fraction. So multiply by 2, you're going to say times 2, but you got to do all parts. Okay, all parts. This part, this part, this part. Okay, so now let's go ahead and simplify. 2 times 1 is 2. It's less than these 2's divide out. Remember, you wanted a 1 right here. That was the whole point of multiplying by the LCD. And so you get 3x plus 1 is less than or equal to 2 times 3 is 6. And now that looks like very similar to the previous problem. And so we're going to solve, we're going to get x in the middle. So I'm going to subtract 1 from all 3 parts. 2 minus 1 is 1. Is less than 3x. Is less than or equal to 6 minus 1 is 5. And then finally dividing both sides by 3 to get x by itself. I get my solutions. My solutions are going to be between 1/3 and, this is x right here, 3 divided by 3 is 1, 1 times x is x, so between 1/3 and 5/3. And so your graph would look like this. So remember, always go from smallest to largest. So 1/3, 5/3, parentheses, brackets. There's no equal sign, parentheses, equal sign, bracket. So parentheses, brackets. And then you shade it in. Okay? And so your interval notation now, you're going to say, just read out what you see. Parentheses 1/3, comma, 5/3 bracket. That's all you do. All right, and then finally number 3. So number 3, we have this though. Okay, so you got to be careful with number 3. And number 3, we have -7 is less than -2x plus 3 is less than 5. Okay? All right, so we got to get x in the middle. So I'm going to subtract 3 from all 3 parts. So -7 and -3 is a -10 is less than -2x. This is 0. Is less than 5 and -3 is a +2. All right, now I got x by itself. All right, now I want you to remember this. If I cover this up, remember you're dividing by -2, right? Well, remember what you do if you divide and multiply an inequality by a negative number? You have to reverse this. Okay, so you're dividing all parts by -2, so you have to reverse both those inequality symbols. And I want to make a point here. The inequality symbols have you pointing in the same direction. Less than, equal, less than. Less than, equal, less than. Less than, equal, less than. See, less than, right? Okay? Less than, equal. Less than, equal. You cannot have, what I'm trying to get the point, and this was discussed in the lesson, you can't have less than and all of a sudden greater than. All right? You can't have greater than all of a sudden less than. So if you divide this side by -2 and you reverse this, you better do this one too. This side also. Okay? All right, -10 divided by -2 is a +5. Is greater than or equal to, reverse, this -2 divided by -2 is 1. 1 times x is x. Is reverse, less than 2 divided by -2 is -1. Now, here's the problem some students are going to make a mistake with. If you look at the graph, remember when drawing a graph, you always go from smallest to largest. So this is a mistake. Don't say 5, -1. 5, -1. That's a mistake. Okay? So that's a mistake. Remember, you must go from smallest to largest. So what some students prefer to do is this. They prefer to rewrite this to where the smallest number is listed first. So you're just rewriting it backwards. So you're going to say -1. See, this is this little arrow, the less than is pointing towards -1 right here. So you can say less than, just like this, reverse it, x, and then less than equal to 5. All right? And so then the graph will look like this now, -1, 5, no equal sign, parentheses, equal sign bracket, and then shade in. And so your interval notation now, interval notation then will be from parentheses -1, comma, all the way to 5 bracket. All right. Now, let me just say this. If you wanted to do set builder notation, just to let you know. Now, they didn't ask you to do that here, though, okay? That wasn't part of the directions. But we did talk about it, and it could be on my math lab. So set builder notation, you're going to say the set of x's such that, and it does not matter which one of these you use. I just want to make that point. So if you want to use this, you can. So such that 5 is greater than or equal to x is greater than -1. Or you could have said the set of x's such that -1 is less than x is less than or equal to 5. Does not matter. Okay? All right, so that's going to take care of the key to Topic 7, Part B.